Hi, grade 7 students. This is a new mathematics lecture. It's lecture 4, and the title of our lecture or our lesson is Congruent Triangles, the two cases 2 and 3. In a previous lecture, we studied about congruent triangles 1, which was the first case of congruent triangles, which is ASA. Now we will study the two other cases, which are SAS and SSS. Let us start together. So the objectives of this lecture are identify the second case of congruent triangles, which is called SAS. What does this mean? If two sides and their included angle in one triangle are equal to two sides and their included angle in a second triangle, then these two triangles are congruent by side angle side or SAS. The second one, identify the third case of congruent triangles, which is called SSS. If three sides in one triangle are equal to three sides in a second triangle, then these two triangles are congruent by side, 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 or SSS. Reminder, this is what we studied in congruent triangles 1. In congruent triangles case 1, we said if two triangles are congruent by angle side angle or ASA, if a side with its two adjacent angles in the first triangle are equal to a side and its two adjacent or included angles in the second triangle. For example, if I have a triangle ABC and a triangle PRQ, from the figures, we can see that side BC is equal to side PQ, angle ACB is equal to angle PRQ, angle ABC is equal to angle PQR, then these two triangles are congruent by ASA. In the two triangles XYW and ZYW, we can say that YW is a common side between the two triangles. Angle XYW is equal to angle YWZ. Angle XWY is equal to angle ZYW. Then these two triangles are congruent by SAS. Now, sorry, ASA. Now, in the last figure, we have a triangle ABC and a triangle CDE. We can see from the figures that side AC is equal to side CE, angle BAC is equal to angle DEC, and angle BCA is equal to angle DCE. So these two triangles are congruent by angle, side, angle. So these are three examples. You can practice them in order to revise the first case, which is ASA. Now, congruent triangles, case 2 and case 3. Case 2 is two triangles are congruent by side, angle, side. So two triangles are congruent by side, angle, side. If two sides with their included angle in the first triangle are equal to two sides and their included angle in the second triangle, this is called SAS. Let me tell you, what do we mean by included angle? As you can see, we have a triangle ABC. We have BC is marked and CA is marked. The included angle is the angle between the two sides. This is the included angle. Triangle YZX, between side YZ and side ZX, the included angle is YZX. So these are the included angle in the two triangles. It's an angle between two sides. Also in the second figure, if I'm talking about the triangle ACB, AOB, ACB, sorry, and the triangle DCE, between side AC and side CB, this is the included angle. Between side D C and CE, of course, this is the included angle. So this is the included angle between the two sides. In the last figure, in triangle PRQ and in triangle RQS, between side PR and side RQ, angle PRQ is the included angle. Between side RQ and side SQ, angle RQS is the included angle. So this is the included angle between the two sides. After knowing what do we mean by included angle, now let's practice an application. I have this figure in front of me. The question is, show that the two triangles PRQ and SRQ are congruent. If I look at triangle PRQ and SRQ, I should see the marked elements, but before I should write a starting sentence. In triangles PRQ and SRQ, first I see side PR and side SQ have the same marks, then these two sides are equal. Side RQ is a common side between the two triangles. Angle PRQ here is equal to angle RQS in the second triangle. Then these two triangles are congruent by SAS. Don't forget something very important I told you about before. Suppose I have an isosceles triangle ABC. If I draw AE, what does AE represent in triangle ABC? AE is at the same time a height or a perpendicular. It's a median, it's a bisector, and it's also a perpendicular bisector. Now the last case in our lesson, congruent triangles, is the third case. Two triangles are congruent by side, side, side. If three sides in the first triangle are equal to three sides in the second triangle by SSS. Let's do a practice. The two triangles below, KLM and OPQ, are such that KL is marked equal to OP, KM is equal to OQ, and LM is equal to PQ. Let's say why are these two triangles congruent? Of course, first we start with the starting sentence. In triangles KLM and OPQ, we have side KL is equal to side OP by given, side KM is equal to side OQ by given, side LM is equal to side PQ, of course, by given. The ending sentence, the two triangles KLM and OPQ are congruent by SSS. Now, which method can be used to prove the triangles are congruent in the following? If you have this figure, in this figure, if you are talking about this triangle here and this triangle here, which case do you use in order to prove that they are congruent? Case 1, case 2, or case 3? I can see that this side is equal to this side is equal to this side, and we have a common side, so here we use they are congruent by SSS. So this is a common side, so they are congruent by SSS. Now the second figure, we have two triangles, KOE and LOF. Which case of congruent triangles do you have here? We can say that KO is equal to OF, OE is equal to OL, angle KOE is equal to angle LOF. Since these two angles are vertically opposite angles, then these two triangles are congruent by SAS. This was our lesson for this week, my lovely students. Please study and write notes about this lesson on your math copybook for next time. And until we meet, please take care and be safe. Goodbye.